These are the two syntheses I mentioned in my intro, going from cyclopentane to cyclopentanol and then this one over here. Okay, so let's go ahead and do both of these syntheses. So the first one, which is cyclopentane to pentanol, there is absolutely nothing on cyclopentane, right? There is no functional group to go from there to make an alcohol. So which means you have to generate the functional group yourself, okay? And so the best way to generate a functional group yourself in any kind of alkane is to do a free radical, okay? So we'll go ahead and do Br2 H nu, which is a free radical reactions. H nu is just energy. So this is a free radical mechanism which will give you then a bromine on here. Now that you have a wonderful leaving group, now you can just go ahead and do a substitution, which is then simply a hydroxide. Okay, now the sodium ion is there, remember, okay, the counter ion is there. I'm just not writing it, and you don't have to either, it's okay. So then you just do an SN2 substitution with hydroxide and you are done. Okay, so one synthesis down, very short synthesis. Now let's look at the next one. Okay, and the next one is going from 2-pentanol to this compound here. I think this was a hexene. So to do this kind of a synthesis, here if you look, I've actually added 2 carbons, right? So here we have the alcohol. The alcohol is not there anymore, but we have an ethyl group there, and we also have a double bond here. So the pentane chain, that one is still there, okay? All of that is still there, but we've added 2 carbons, okay, on here. So in order to add 2 carbons, the only way you have learned so far to add carbons is to do Grignards, okay? So which means that's what we're going to have to do. I'm going to show you a little bit of retrosynthesis here, okay? How to approach things backward. So I'm going to go ahead and draw this molecule. So in retrosynthesis, you take the product and then you work your way towards the starting material, okay? So we're really going backward in this, and the backward arrow is this, the retrosynthesis. So in this case, because we have an alkene, and the only way we know how to make an alkene right now from all the knowledge that we have is from an alcohol. This alkene looks like a Zaitsev product, so which means that my alcohol should be over here, which is a nice tertiary alcohol to give me a Zaitsev product, okay, the more substituted alkene. So which means that I have to turn the alcohol into an alkene. Remember, I'm going backward, okay? So to get an alcohol, I can do a Grignard, okay, over here. I can do a Grignard reaction over here because that's the only way I know how to form a carbon-carbon bond. However, to do a Grignard, I need a carbonyl, okay? So what am I going to add? Okay, so if you look at your fragment that you're given here, the compound to start with, this is a 5-carbon, okay? And here is your 5-carbon chain right here. Okay, so let me take a thicker one. This is your 5-carbon chain here, which means that we are adding this one. All right, so which means we have to add 2 carbons to this. So which means that I will need, excuse me, let me get the proper color here. So which means that I will need a carbonyl over here plus a 2-carbon fragment, which could be my Grignard then, okay, MgBr. That's what I need. So now I need to figure out how to use my starting material to form this, and that is not hard at all because I am good in oxidations. Okay, so anyhow, this is going backward, okay, doing a synthesis. Now I just need to fill in all my reagents, okay? So the reagents here that I will fill is from alcohol to ketone, I will need PCC. I can use KMNO4 also, okay, because it's a secondary alcohol. It's primary alcohols you have to worry about, okay, because they can get oxidized to carboxylic acids also. But secondary alcohols, no problem. You can use PCC or you can use KMNO4, okay. So that will give me my ketone. That ketone I'm going to react with this Grignard reagent, which by the way I can get from an alkyl halide and magnesium, right? That's what I need in order to form that Grignard. Once I react those, then I will get my alcohol. So now I'm taking you backward, right? So I'm going, or I should say forward in a way. So now with the alcohol, to get the alkene from the alcohol, I will need to dehydrate this sulfuric acid, concentrated sulfuric acid. So that is this synthesis. Now, I mean, if you are good in thinking forward, it's okay. All right, you can do that, but sometimes you have to think backward. Okay, and I'm comfortable going forward and backward, and I would like you to start getting comfortable going backwards also. Okay, so here is a retrosynthesis for you.